Sometimes, instead of giving y as a function of x, I can give the x and y coordinates of the points on my graph as two separate functions of a third variable. A lot of the times the variable we use is the variable t. So here's an example. I could give you two separate functions. I could tell you that x is equal to 3 times the cosine of t, and y is equal to 2 times the sine of t. Now it turns out if you graph this, you're going to get an ellipse. But this is just an example of a case where we might, instead of giving y as a function of x, give both x and y as two separate functions of a third variable, t. We call these parameterized equations, and the variable t, whatever the variable of the two equations is, that's called the parameter. If it's interesting to you, if I'm not mistaken, you can click on this link and play a YouTube video from you can play a Khan Academy video which talks about parametric equations. I don't actually need you to know all of this information, but do know that some functions are given some equations, some graphs, some relations are given as two separate functions, one function for the x and one function for the y. Okay, so remember what we're doing here. We have just learned the chain rule. If I have y, and y is a function of u, but I want to know what dy dx is, I want the derivative of y with respect to x, I can do that if I find the derivative of y with respect to u, and then multiply by the derivative of u with respect to x. So just notice I could change the variables around. There's nothing special about y and u or x. If I had a function y that was a function of x, and x was a function of t, then I could find dy dt by taking the derivative of y with respect to x and multiplying by the derivative of x with respect to t. So same process, I'm just using different variables here. So this is how we're going to be able to use the chain rule to find derivatives, so slopes of parameterized curves. So here we have that equation I just wrote. And if dy dx is the slope of a curve, that's the thing I want to find, usually the slope of the curve, the slope of the tangent line to the curve, I can isolate dy dx in this equation. I would do that by dividing both sides of this equation by dx dt. So here we have the slope of a curve that's given with two parameterized equations. Dy dx, the slope, is dy dt divided by dx dt. So the slope of the derivative of the y function divided by the derivative of the x function. So here's an example that's not on your paper. If I have a parameterized curve, so the x coordinate is given by 3 times cosine of t, and the y coordinate is given by 2 times the sine of t, I could graph those. I would get a picture that looks like an ellipse. I could imagine wanting to find the slope to this curve at some point. So I can find that curve, the slope of the curve, using the chain rule for parameterized curves. So dy dx is going to be dy dt divided by dx dt. So my first step, this is the x function. I want to find derivative of x with respect to t, and that's okay because x is given as a function of t. So dx dt is going to equal -3 sine of t. I'm going to find the derivative of y with respect to time, with respect to t. Dy dt is 2 times the cosine of t. So there's my dy dt. And then that formula that you have written in at the top of your notes paper, that's the formula you have to know. Dy dx is dy dt divided by dx dt. You could simplify that. Happens to be -2/3 cotangent of t, or again, simplifying is not required. So here's an example that is on your paper. I have a parameterized curve. The x-coordinates given by the function secant of t, and the y-coordinates given by the function tangent of t. Can I write the tangent line to that function at the time when t equals pi over 4? Well, so same rules for writing the equation of a tangent line. I still need an ordered pair, and I need a slope. So here, to figure out an x and a y value, an ordered pair that goes together, I have to have a t value, a time value I can plug in. So I'm actually going to start by finding the ordered pair, the x1 comma y1. And I've been told that time is pi over 4. So to find the x-coordinate of the point to which I'm going to find the tangent, I'm going to plug in pi over 4 for t. So x is going to be the secant of pi over 4, and the secant of pi over 4 is radical 2. To find the y-coordinate, I'm going to plug the t value, pi over 4, into the y function. Y is equal to the tangent of t, so when time is pi over 4, y is going to be the tangent of pi over 4, which is 1. This tells me I have the ordered pair radical 2, comma 1. Now I'm going to find the slope. I'm looking for dy dx, and I know that to find dy dx, I'm going to find dy dt and divide by dx dt. So to find dy dt, I need to take the derivative of tangent of t. Well, that's secant squared of t. Oops. Secant squared of t. To find dx dt, I need the derivative of secant of t. Derivative of secant is secant t tangent t. Now I have dy dt. I have dx dt. I just make them into a big fraction. So dy dx is going to be dy dt over dx dt. You can see here I have replaced dy dt with secant squared of t. I've replaced dx dt with secant t tangent of t. You'll notice that a secant t from the numerator cancels with a secant t from the denominator. Or if it's the free response section, you don't actually have to simplify. And then we have this function, secant of t over tangent of t. And then we have one last step, well, two last steps. I'm trying to find the slope of the curve, or the slope of the tangent line to the curve at the time when t equals pi over 4. So what I want to do is I want to plug pi over 4 in. You can see this notation here. I want dy dx when time equals pi over 4. So I'm taking this function, secant t over tangent t, and replacing t with pi over 4. Secant of pi over 4 is radical 2. Tangent of pi over 4 is 1. And I have a slope that is radical 2. I got one more step here. Oh, did I? So now I just have to collect together all the stuff I did. At the beginning, I found an ordered pair was going to be radical 2, comma 1. And I found a slope that's equal to radical 2 at that time, so for that ordered pair. So I'm going to write the equation of the tangent line. Y minus 1 equals radical 2 times x minus radical 2. Feel free to leave your answer in that form.